Number 19, we're looking for an assumption required by the argument. So let's read the argument. First sentence tells us that the differences in distance from Earth between the stars in any distant galaxy are negligible when you compare that to the vast distance to that galaxy itself. In other words, if you take two stars in a distant galaxy and you compare their distance to Earth, then the differences between those two is pretty negligible compared to how far away that galaxy is. Right? In other words, the galaxy is already, millions and trillions of miles away. So if one star is like a little farther from Earth than the other one, it's not really going to make a difference. It's pretty negligible. They're both pretty much equally distant from Earth in the scheme of things, right? That's the point of the first sentence. And then we say, therefore, if two stars are in that same distant galaxy, if there's a significant difference in the apparent brightness of one of those stars, so in other words, if one of those stars is appearing brighter than the other one, that must result from differences in how brightly they are actually burning. In other words, because according to sentence 1, it can't be because one is closer than the other one, because we said any difference in distance from Earth is negligible. So if you see one that's brighter than the other one, it must be that it actually is a brighter burning star. Therefore, in conclusion, here's the conclusion of the argument, we should be able to determine how a star's relative actual brightness, which according to sentence 2, we can figure that out. We can look at the relative actual brightness from two stars based on how bright they appear. According to the conclusion, therefore, we should be able to determine how that correlates with other characteristics by studying stars in that same distant galaxy. Now, always be very suspicious of things that are mentioned for the very first time in the conclusion. When the conclusion mentions something that was not mentioned anywhere else in the paragraph, that very much most of the time is going to be involved with the assumption, because there's clearly an assumption made because we just mentioned something for the first time. What's the thing we mentioned for the first time? Well, the conclusion is saying that we can determine relationship between the star's actual brightness and other characteristics in that distant galaxy. Now, according to everything we've read so far, we are able to tell the actual brightness. We are able to figure that out, right? That's what sentence 2 told us, is that we can figure out what the actual brightness is of those stars. The conclusion says, therefore, we should be able to determine relationships between actual brightness and other characteristics. We were never told about whether we can figure out other characteristics. We were told that we can figure out actual brightness. We were never told whether we can figure out other characteristics. Maybe those stars are so far away that all we can tell is how bright one is versus how bright the other one is. Okay, great. But who says we can figure out other characteristics so that we can determine this relationship, or whether there's a relationship between those other characteristics and the brightness, right? So that seems to be the jump, is that assuming that there are these other characteristics that we can determine that will be able to do this thing that the conclusion is saying that we can do, right? That's the jump. That's the new piece of information that we need to assume that that's something that we can do. So let's look for something like that. And the answer choice is let's look for something that reflects those other characteristics and the fact that maybe we can figure those out. Let's look for something like that. And the answer choice is because there doesn't really seem to be anything else that's being assumed here. That's the only new thing in the conclusion that wasn't really tied up. A, in order for this argument to work, do we have to assume that if two stars are in two different galaxies, notice the word different galaxies, then it's not possible to determine whether or not they are approximately the same distance from us? What does that have to do with the argument? The argument is only about stars in the same distant galaxy, right? So why would we have to assume anything about what we can or cannot figure out about two stars in two different galaxies? Why would that have anything to do with this argument? And therefore, for that very simple reason, A is wrong. B mentions elements that are burned by these stars. So it says if there's any two stars that are in the same distant galaxy, B says in order for this argument to work, you have to assume that from Earth we can tell differences in the elements that they're burning. That's a totally new concept. Who said anything in this paragraph about being able to tell what element a star is burning, right? We did say that we do have to assume that there are characteristics of these stars that we can discern from Earth, that we can tell from Earth. But you don't have to assume that it's differences in elements, right? We're looking for a necessary assumption here. Why do you have to assume that you can tell differences in elements? Maybe there's 100 characteristics that a star has, and maybe only 50 of them we can tell from here, and therefore the argument is relying on the fact that we can discern those 50 characteristics and find any correlation between those and the actual brightness. Maybe the elements that they're burning, maybe that we cannot tell from Earth. In other words, maybe B is false, But the argument still might work because maybe there's other characteristics that we can discern from Earth. So why would it specifically have to be differences in elements that they're burning? That's what we have to be able to discern from Earth. That's a new random thing that B just came up with. So it doesn't make sense that that would necessarily have to be assumed for this argument to work. C, do we have to assume that the stars in our own galaxy are not all approximately equidistant from Earth? Now, we're not talking about stars in our own galaxy. We're talking about stars in distant galaxies. That's what the whole argument's about, right? Sentence 1, the differences in distance from Earth between the stars in any one distant galaxy, right? Sentence 2, thus, if two stars are in the same distant galaxy, right? And the conclusion, also, we're talking about studying stars in the same distant galaxy. So we're not talking about stars in our own galaxy. That has nothing to do with our argument. So for that very simple reason, you can cross off C pretty quickly. D, do you have to assume that there are stars in distant galaxies that have characteristics other than brightness that we can discern from Earth? Yes, that's exactly what we have to assume. That was the only thing missing. That was the only jump made in the conclusion of the paragraph, as we pointed out when we read it. But even if you didn't predict the answer, you should be able to read D and say, oh yeah, we do have to assume that there are other characteristics that we can figure out other than brightness. Because if D were false, if we negate D, remember that's the litmus test for a necessary assumption. If something's truly a necessary assumption, that means if you make it false, the argument should fall apart. Let's make D false. Let's say there are no stars in distant galaxies that have any characteristics that we can discern other than the brightness. Well, that ruins the conclusion, because the conclusion is saying, oh, we should be able to determine how the brightness correlates with other characteristics. If we just study these stars, we should be able to see, oh, here's their brightness, and here's some of their other characteristics, and we can find the relationship, the correlation between those things. But if you make D false, if there are no other characteristics other than brightness that we could even discern from Earth, then how on earth would you be able to do that? No pun intended. How would you be able to do that, right? And therefore, since D false ruins the argument, that means D being true is necessary for the argument. So it's exactly what we were looking for, and it is the correct answer. E, in order for this argument to work, do we have to assume that if there are significant differences in how far away two stars are from us, then those stars are going to differ significantly in how apparently bright they appear? So here's the thing. This paragraph tells us that we're dealing with two stars that are in a distant galaxy, and we are told explicitly in the first sentence that there is no significant difference in how far away they are from Earth, right? Because we said any difference between them and how far away they are from Earth is negligible compared to how far away that galaxy is to begin with, right? So this whole argument is dealing with two stars in a distant galaxy, which we're told there is no significant difference between them and how far away they are from Earth. So E is talking about two different stars than the ones that we're talking about in this paragraph, right? E is saying, well, if you have other stars that maybe are not in a distant galaxy where there is a significant difference, then by the way, you should know that they will differ significantly in apparent brightness. Okay, but that must not be what we're talking about in this paragraph, because this paragraph is talking about two stars in a distant galaxy where we are told explicitly in the first sentence that there's no significant difference. In other words, it's a negligible difference. Negligent is the opposite of significant, right? So clearly E is talking about something that this paragraph is not talking about, and therefore it cannot possibly be a necessary assumption. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.